Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides more practice with using Z-scores. So let's get started. In the previous mini lecture, we learned about Z-scores, how to calculate them, and how to use them. Z-scores play a huge role in some of the tools in our statistics toolbox that we'll get into later in the course. So let's gain some extra practice with using Z-scores. We'll start with LeBron James, one of the most successful basketball players of all time. He is 6 feet 8 inches or 80 inches tall. Based on the statistics assembled for the heights of a sample of statistics students, that height converts to a Z-score of 3.08. So how many standard deviations is this height above the mean value? I'll give you a moment. Well, a Z-score of 3.08 represents a data value 3.08 standard deviations above the mean. This is the definition of Z-score. It tells you the number of standard deviations a data value is above or below the mean. Now, if you wanted to be taller than LeBron James, which of the Z-scores that you see here would you prefer and why? I'll give you a moment. Well, you'd want the 4.00 because to be taller means you need to move away from the mean value to the right. And 4.00 is the only Z-score that is to the right of LeBron James's Z-score of 3.08. Every other Z-score would mean LeBron gets shorter, or actually you get shorter than LeBron because your Z-score would move to the left towards more negative territory. Next, let's consider an example involving plastic waste. Sample of the weights of plastic waste discarded by households inside a certain community during a given week was recorded. The mean weight is 1.911 pounds and the standard deviation is 1.065 pounds. Plus, your neighbor discarded 5.28 pounds. What is the difference between 5.28 pounds and the mean weight? I'll give you a moment to calculate that. Well, you should get 3.369 as you see here. Now, how many standard deviations is that difference? Again, I'll give you a moment. Well, to get the number of standard deviations, just divide the difference we just calculated by the standard deviation. This gives us 3.16. Now, what is 5.28 converted to a Z-score? I'll give you a moment. Well, the prior two parts we just completed together comprise the calculation for the Z-score. If you look closely enough, you should be able to see we have the same answer because we performed the same calculation. Now, if we consider weights that convert to Z-scores between -2 and 2 to be neither significantly low or significantly high, is 5.28 pounds significantly low or significantly high? I'll give you a moment. Well, the weight value of 5.28 has a Z-score of 3.16, and because 3.16 is greater than +2, we're outside the range of usual values on the right side, which makes 5.28 a significantly high value. Let's go back to our speed dating example. What is the mode, and is this mode value significantly low or high? Pause the video here, go open the speed dating file in our StatCrunch group, and get your answers to the question. Then come back here, and we'll see how well you did. Well, I hope your results window looks like this. The mode is clearly here, but so are the mean and standard deviation, which we need to calculate the Z-score so we can judge whether the mode is significantly high or low. To calculate the Z-score, we substitute our values into the Z-score equation and punch it out. this gives us 0.76. And because 0.76 is in the range of usual values, it's neither significantly high or low. Now, what are the min and max values, and are these values usual or significantly low or high? Again, pause the video, go into StatCrunch to get your answers. I'll be here when you get back. Well, your results window should look something like this. If it doesn't, get back into StatCrunch, try again until it does. Now, once you have your min and max values, you can convert each of those values into Z-scores. If you observe those Z-scores, you'll see that both of them are inside the range of usual values that are between -2 and +2. So neither one of these values is unusually low or high. They're both usual values. So we see that each of these Z-scores is a usual value, but between the two of them, which is the more extreme? Again, I'll give you a moment. Well, the more extreme value is the one that is farthest away from the mean. We can easily determine that by taking the absolute value of each Z-score and then selecting the one with the higher value. In this case, that's the min, because its Z-score of -1.9 is farther away from the mean than 1.82, which is the Z-score for the max value. Let's look at one more example involving the world's tallest and shortest men, according to the Guinness Book of World Records. By that account, the tallest man is Robert Wadlow, who in 1940 stood almost 9 feet tall. The locals called him the Giant of Illinois because he was from Illinois and he was, well, giant. Then at the other extreme of the spectrum, we have Chandra Dangi. I'm not sure if that was the right way to pronounce his name, but I am sure he's from Nepal, and in 2012 stood not even 2 feet tall. So if the distribution for men has a mean value of 174.12 centimeters and a standard deviation of 7.1 centimeters, which of these two men has the more extreme height? Feel free to pause the video here, make your calculations, and then come back to see how you did. Okay, let's see how you did. To find the more extreme height, you need to convert both heights to Z-scores. So let's start with the Giant of Illinois. When we convert his height to a Z-score, we get 13.79. When we do the same for Mr. Dangi's height, we find a Z-score of -16.83. So it looks like Mr. Dangi has the more extreme height value. Remember, to gauge how extreme is extreme, you're looking for the value with the greatest distance from the mean, and that value will have the Z-score with the greater absolute value. That's clearly Mr. Dangi, and so he has the more extreme height measurement. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.